now that we have these set up, we just send in, you know, the 2 points to Manhattan and Euclidean, and it's the distances, you know, 2 and 1.4. I'd actually changed these earlier because I thought it was cooler to have 3 and 4. So that then gives me a 3, 4, 5 right triangle, and the numbers are a little nicer and more different. Sort of 2 doesn't turn out nicely. So does that make sense to everyone? Awesome.
If point 1, if variables are immutable, how come you were able to just reassign that?
Which one?
Didn't you? Because you changed point 2 from 1, 1 to 3, 4.
It's so the interactive window. You can sort of redefine stuff because it's an ongoing process. This is like it's not being redefined later in the code. I didn't add it to 1. Point 2 is now always going to be 3 and 4. Does that make sense? Like I just changed the code, not.
But you couldn't have like 2 lines in a row that said let point underscore 2 equal blah blah.
No. Okay. Although I have noticed you can do this in the interactive window. It'll and I don't know if it just shadows it, but I've declared x equals 5 and then been in the middle of doing everything I was doing, redeclared x equals 2 and rerun the code. And that doesn't complain, but that's because it's down here in there. You know. Does that make sense?
Yeah. Can you go to the I don't know if this will take us too far off topic, but could you go to the Minkowski function when it was declared and like step through it a bit to see how it maps to the math? I'm having trouble making that mapping. There's too much new stuff there at once.
Yeah. So Minkowski takes a power and 2 lists. And this is Manhattan and this is Euclidean, basically. And if you think about it, this is just 1 here and then to the power of 1 over 1. So where that would be a square root or a cubic root or something. And so the very first thing I do is the very first thing I do is define the list difference. That just takes the difference of the 2 lists. I didn't need to. I could have used the whole thing in it, but I made it a little cleaner. So here that takes p and takes an x and just takes the value of the x to the power of p. Takes the absolute value of x to a power.
And so this defines a function called absence for power.
Yes.
Okay.
Yeah. And then
could you have defined this difference inside Minkowski?
Say that again?
Could you have defined this difference inside Minkowski?
I could have.
Absolute power.
Yeah. The distance then takes the list difference of the 2 lists. So it does the subtraction in here. And then it maps all of that using the absolute power of p. So it takes this x minus y and then takes the absolute value and takes it to a power.
What's list map to?
List map takes every element in the list and acts on it in some way.
Okay.
And so the very first thing that I had was it list mapped to x plus 3. So it just added 3 to every single element in the list. Whereas this one takes the absolute power to the absolute value to the power of p.
Does p have 2 different meanings in here? So is p like a local variable or a local whatever that isn't a variable?
It's
the abs powered and to Minkowski?
It's being passed along. It's always the same thing.
So in the context of abs powered, p is constant.
Right.
Okay.
And then I just type that into list.sum, which sums everything. And then the final value, here's where it is. The final value that I wanted to return, I just type it out. It's distance to the power of 1 over p. So which is 1 over 1 or 1 over 2, and 1 over 2 being the square root.
And you have 1.0 there, which
just to make it
Force
float.
the P afloat.
Right.
Okay.
And here, I had to force X to be afloat too, just to make it work.
Would it not figure that out on its own because of P?
It wasn't. This is one of those cases where I had some trouble with it.
Okay, fair enough.
So does that help? Does that make sense?
That helps a lot, thanks.
Cool.
So what you're saying is carrying is absolutely critical to have the order of your parameters just right,
Yes.
right?
It,
Whereas if you do it in C#, you wouldn't care because you have the entire tuple in front of you. Whereas in F# it's critical to have the order right.
I'm sorry, I didn't get the point.
it's important to have the order of the parameters. One of the things that I had done was specifically make P be the first parameter, so that was the one that and I believe that's required, if that's the one that you're going to type. Yes. Because down here, to be able to declare Minkowski of 1.0 as Manhattan, if P was the last variable, there's no way to declare that, like, ignore the list variables here, but then put in a P at the end.
So if you want to, you could take current one step further and like pass in
A specific list.
0, 0 is always the starting point.
Totally, yes. And units of measure. Units of measure are like this hugely critical thing if you're doing a lot of financial stuff, some of the scientific computing. And this one I had fun with. We're calculating the wind chill factor. And I went and I kind of learned a little bit about the wind chill factor. Apparently, in North America, I mean, obviously the US and Canada have slightly different because Celsius and Fahrenheit and miles and kilometers. But the North American wind chill factor equation is completely different than the Australian one. The Australians take humidity into account, and it's valid for basically all temperatures. Whereas the North American ones only consider it valid to be at low temperatures. So you don't hear about a wind chill of, when it's 80 degrees outside, or 80 degrees Fahrenheit. But maybe not. Yeah. But this is true, and I don't know how those formulas relate. I didn't look that up. So you declare. You use this special measure declaration with a type to declare that it's like this special units of measure type. It's not sort of a real type. So I will. There we go. And then I had to. So also the wind chill factors are not. They're sort of more indexes than proper formulas. So they have this annoying little part. Okay. There's this annoying little part up here where you actually have to take the velocity to the power of 0.16, which means that in theory you have to take your units to the power of 0.16, which 1F# doesn't do, and 2 is like the 0.16th root of a unit of measure. And like that's teensy. So to make sure that it still paid attention to both miles and kilometers, I added it. So first of all, the actual function is 35.74 degrees times 0.6215 times the current temperature minus the minus 0.3965 times the temperature times the velocity. So it's, let me write that out in a way that will make a whole lot more sense. minus something times the velocity plus something times the temperature and the velocity. So the numbers look long and scary, but it's and there's a lot of text on the page. Yes.
You know, to be a good exercise,
What?
to write a heat index formula and then function,
Yeah.
and then combine those two. And in theory, you should get the Australian one, or
That's
something close.
Yeah, I wonder. It's the Australian one. It was actually listed on Wikipedia, what it was, and I just ignored it because I was like, there's going to be already the U.S. and Canada in here. I don't need to show them Australia also. That's but actually, I kind of like that. So yeah, so to get around to make sure that the velocity was passed in as miles per kilometer or miles per hour or kilometers per hour, I did speak too much. I did leave that as defined, but then I used the convert kilometers to miles and convert miles or kilometers to B and miles to B. These functions up here, where I basically and that's how you cast float, comma B or parentheses B. So I just cast it to a float and then take that float to the power of 0.16. So basically, what this is doing is removing the units of measure from there. So I'm kind of cheating a little bit. But I also had to make the formula work. And it's still validating that I have these miles and kilometers in here. So basically I declare all these types, and then when I declare the types here, I say float of type Celsius and float of kilometers per hour. And then for each, this is just a number, 35.74, but I declare it with the F there so that it knows it's Fahrenheit. And this here, because T is in Fahrenheit, this is still in Fahrenheit, this whole expression. And this one, this is a number which is in Fahrenheit times this function here, where I've converted it back to a float, and so it doesn't have anything, so it's just a float. But then that stays in Fahrenheit. And then, this final one is just a number times T, which is in Fahrenheit, times again the velocity function where I remove the units of measure. So this keeps it all Fahrenheit, and it guarantees that I'm returning a value that is Fahrenheit. And if I try to either declare this as something that's really C, it'll start throwing up red squigglies all over the place. If I declare one of these numbers as C, it'll throw up squigglies that won't let me. The unit of measure F does not match the unit of measure C. And then if I do, let's define all these functions. And then what I've done is declare temp and wind speed for New York, which are probably not at all, definitely not at all accurate. And send those in. And so if it were 6 degrees Fahrenheit out and the wind was at 45 miles an hour, the wind chill would be minus 21. If I tried to send this in at 6 degrees Celsius, it'll automatically put a squiggly under New York City temp, and it'll tell me that the unit of measure F does not match the unit of measure C. So it's an additional check when you have all of this set up that you are sending in the exact right thing. You're not mixing and matching your units. You're not being dumb about something. It's it's making sure. And then the same thing here. If I send this in as kilometers, even though I'm sort of cheating and taking that out, it still knows because I can't send in because of the up here. It's the temperature is a float of C and the velocity is kilometers per hour. So that's why I kept it in there to make sure that it's still tracking the kilometers per hour, but it comes through and sort of removes them because it really is just an index and it doesn't depend on the 0.116 root stuff. The velocity.
So how much of this is part of the language versus what you declared in terms of these units?
F and C are just basically I could have called them Q and P, but the unit of measure functionality, and they do have there's like a standard library that has some of them in it. I honestly haven't used it, but I know that people do, and it's very important.
Okay, so it's basically just a list of those measurements or measure declarations.
Yeah, so
Okay.
it's, it has like the official meter definition kind of thing.
Now, is there anything like on kilometers per hour and miles per hour, is there anything about like CAM/HR, anything there that indicates division, or and like CAM and HR are separate, or?
Yes, it knows that CAM and HR are separate and that this means CAM per HR. And so that in a couple of cases, while I was messing around with it here, I was doing stuff totally wrong, and it'd come back with like, you're trying to send in kilometers per hour squared or kilometers squared per hour squared, and you're wrong. And so it was able to do that.
Does it know about?
I'm sorry.
Does it know about kilometers as a unit of measure now, and hours as a unit of measure, despite you not declaring those explicitly?
It knows that this string KM is a measure. It doesn't know that it can't associate, because of what I've done here, and I haven't used the standard official library, whatever it's called. It doesn't know that that is a kilometer. It just knows the string KM is something that is different from the string HR.
Well, like, so could you say let nyc-temp equals 6.0 bracket KM bracket?
And then it would still, it'd be angry because KM.
It'd be angry down there, but yeah, it would let you do that assignment.
Yeah, and if I did something I haven't actually tried, yeah, it doesn't even know what KQ is.
Nice. Okay. I'm good.
Oh, yes, I'm sorry.
So if there are units of measure, is there some language that would allow you to compile, do conversions?
There might be in the standard library. I don't know offhand. I saw a couple examples of people writing their own conversions from one thing to another.
But would you, so if you have to write your own, does F# help you in any way, at least to make syntax better?
I think so. To make what better?
Syntax, because
Oh.
it's very good.
It'll do this. I don't know that it would do any more than this.
Okay.
I suppose I'm still not sure if that helps. With the standard library, there might be a whole lot more included. There might be conversions on. I have not even looked at it. This is most of what I know about unit of measure.
So basically, this is only guaranteeing that you're going to pass the value that you're passing is of the type that you're interested in.
Exactly. Yeah. So it doesn't guarantee that it still is even the right number or the right order of magnitude, but it's an additional check that is kind of an awesome one.
So if you remember the shuttle crash, that was because somebody actually mixed the units in their code. Somebody assumed meters, somebody else assumes.
Yeah, it happens a lot.
And so
Not some because
if you program it in, it doesn't guarantee sameness of the number. That's what you do. But it actually guarantees consistency.
inclusive units.
And so. We run all of these, and then the Canadian wind chill factor is basically the exact same thing with different constants out front because Celsius is different. But it has the same setup. So you can see that this when I send in Celsius in kilometers per hour in Montreal, everything still works.
And the only reason you could embed the convert function is because it was converting it attached to the value itself, right? And does the parentheses take
The brackets or what?
the parens?
Line 93.
Oh, yeah. So the convert miles to velocity.
Right.
This is where I cheated and used 86 and 87 to sort of remove the units of measure from velocity, because the wind chill needs to be a number in a temperature, and it doesn't really depend on velocity, or the units don't depend on velocity, whereas obviously the equation does.
And how is it that you cheat?
basically I took, I declared velocity to make sure it's a float in kilometers per hour or miles per hour. But then I use this convert kilometers to a V, in both cases here. And what that does is just set it to a float.
Oh, that's the magic.
Yeah, so it's converting it here into a float. And this is, whoever was asking before about conversion, this is exactly how you do it. And then it takes it to the power of 0.16. Because it couldn't, it can't take a unit of measure to the 0.16 power either. So I had to get rid of it, and also it didn't fit really well.
Potentially, what you could have done is declare the constant, the 0.3965, as with a unit of 1 over whatever velocity you have.
I thought about that, but it's right, and that'll then remove it, and then I can take that float just so that that would work.
On line 87, you mentioned that white space is significant. Is there any significance to 2 spaces versus 1 space above it? So when is white space significant? When is it not?
When it's from row to row.
Okay.
So when you're making it into a function or not. And this here where it wraps, that's wrapping. If you see there's no line number,
Right.
that's not significant white space being weird.
So between line 89 and 90 is it the line break that's significant or the line break in the 4 spaces?
It's the indentation of the 4 spaces.
Okay, so if those 3 spaces, it wouldn't work.
It would as long as it's all exactly the same.
As long as every line in the function is the same. Gotcha.
And previous functions. Like your entire program needs to match up.
Oh, snap. Okay.
Yeah. But that means that you don't have like 30 extra lines of brackets. And,
Right. Yeah.
yeah. Semicolons laying around that you don't actually need. So does this make sense to everyone? Does it? The units of measure is awesome. One final little thing. This, I will admit, I actually I started writing something and I don't remember what I was writing, but I needed an operator that did this, that just something basic, and I actually found this on somebody's blog, and I have been using it so long I don't remember where. But this is such a great example of declaring operators and bringing in .NET libraries. So you can declare your own operators in .NET and in F#. And to let, with this, the brackets, the parentheses around it, the operator that you want to use, and then left and right. The reason this guy had created it was because he had been using Ruby a long time and was just pissed off that this operator didn't exist. Like, I always want to use it. It's not here, and why don't I have it? So, created it. And it's actually, so what it does, it creates a cache, it creates of the right operator. So it's basically just what's in the union of the 2 lists. So it takes the right list, creates a hash set, which is just a single list, but no multiples in it, and then filters that on what's in the left. The hash set's a little faster. So you can see that I'm using open to bring in system collections generic. I'm using the hash set. I'm using hash identity structural, and I declare it. It works, and then I can just use this operator wherever it has been previously declared. One of the things I'll do is just have like an operator for a basic library function. Yes.
Might be a weird question, but it's got open with
Yes.
close.
I don't think
Is there a way to unload like a library?
it just does this, right?
It's at program termination.
Yeah.
You can't forcibly inject a module out of scope like that.
It is scope.
That's true. It is scoped, but you can't explicitly unload it.
Well, you can put the open wherever you want,
So
pretty much.
if I do an open inside the function,
You can,
is it going to be unloaded at the end of the function?
it's not loaded, it's just about visibility.
Okay.
Does that?
In other words, open isn't really loaded. loading a module. All Open is doing is like it imports in VB.NET or using in C#. It's just, you don't have to fully qualify the value. It's just saving you having to fully qualify the path to the value.
Okay,
It's not
I was
physically,
taken aback by a load.
it's not physically loading the module
Okay.
into space.
There is no way to open only specific classes within a particular space. Is there? Let's say I want to import within generic a hash set, but I don't want anything else.
No.
You guys,
Ideally, it's more necessary.
Yeah.
sorry.
No.
So on line 109, that calls the hash set constructor that takes two parameters.
Yes. What's your question?
Yeah. Where does, what's the apostrophe A come from? Generic. Is that? Yeah, so it's passing a particular type. Where's that type come from then?
Whatever it is that you're passing in. So it's listing, it's not a numerical. So it infers it from what you're taking the union up. I assume. I don't know. I didn't play around with that. I didn't change that.
Could you have like apostrophe Q there, or does A?
No, the A is, so it's, and this is something that I've used and don't know a ton about, but it is just the generic unit type. Yes?
Is that a union or is it an asymmetric?
It does. Yeah. The intersection, I'm sorry, not the unit. I know that. But actually.
So like if you use, say you had a dictionary there, then you could say like apostrophe A, comma, apostrophe B to get the type of both the parameters and the operator.
I'll think about that.
All right.
Because honestly, I'm not sure. And I would pay more attention to scope because I did start with it. But yeah, like I said, so it returns 36912. So the 115 is obviously 115. This is 0 and steps and threes, so it's everything that's a multiple of 3 in the list one is the intersection.
So it doesn't complain that 25 isn't divisible by 3. It just goes to 24 and stops.
Right. Yeah. So whatever it just knows that doesn't fit in. So those are all the samples I had. We come back. I had wanted you guys to do a couple. If it's getting too late, if we want to go, I can just show you examples. Or I can pass out stick theories. If you look at them, walk through them. Oh, or not. Okay, so here, this is what we were going to do. Take pictures, it's awesome. And then that's it. So if we want to, I will leave this up until the battery dies. And if you guys want to have further discussion, then I can pass out extra stickers if you want. Thank you. Okay, just take one second. So thank you guys.
Great. gonna have your slides on?
We're gonna go across the street and have the